All right, let's see if we can get this going. We just spent chapter 1 looking at limits. Way back at the beginning of chapter 1, probably the first day of class, we talked about these two special situations. One of them was, how do you find the slope of something at just exactly one point? We've known this slope equation for quite a while, and it's just the difference in y values over the difference in x. The rise over the run, delta y over delta x. There's so many ways to say it. But really, we're just subtracting two y values over two x values that tells us the slope of something. How do we deal with this at one point? Calculus is about finding the change of things, the rate of change at an instantaneous moment. I'm not talking over a time period or between 2 points. I'm talking, boom, right at that point, right at that moment. So what we have to do is adapt this, and we talked about this a little bit in our example of slopes. So what I've chosen to do is create a second point. That point, well, we could say A and B, or, x1 and x2, but what I'm going to do for the sake of this, by the way, that's the function. I'm just going to get that out of the way, what that function is at. What I'm going to do is I'm going to call the first point, the x coordinate is x, and the next one is x plus something else, plus some small constant, x plus c. And so when we look at the y values, instead of saying y1 and y2, we're going to say f of x, when the x value is that, and when the x value is this, you can get the y coordinate by plugging that into the function. And that's going to make our new slope equation look something like, well, it's going to look like that. We're plugging in the second y coordinate minus the first y coordinate, and the second x coordinate minus the first x coordinate. I know it looks a lot more complicated. Wouldn't it be easier just to use y2 and y1? Sure. But look how this plays out. Okay, first of all, let's take a look at the denominator here, and I bet there's a way of simplifying it. That's going to be our traditional way of writing out the slope between 2 points when we're trying to do derivatives. Here's what I mean by that. Let's go back to this example. I drew some random point over here. What we're trying to do, though, is find the slope at one particular point. Not between 2 points, but at one particular point. So I'm using this. I know how to find the slope between 2 points. It's something I've done for a while. I'm very proud of myself. Is this orange line an estimate for this blue line that we really want to figure out? Is that an estimate for the slope? The answer is yes. Yes, it is an estimate. However, there is another question here. Is it a good estimate? The answer, nah, it's not that good. The slope of the orange line and the slope of the blue line, they look pretty different. So, do you remember what we do from here? What if we make the points a little closer? What if I take C, and C is just a slightly smaller distance over here? These 2 points are much closer to each other, so is the green line a better estimate for my derivative, for my slope at one particular point? The answer is yes, it is better, and yet we can still improve upon this. As each successive line, as our second point draws closer to the first one, each successive line from the orange to the green to the red to the purple becomes a better estimate for what the slope of that tangent line, the slope of that line going through 1 point, they become a better and better estimate for it. So how do we actually get this to work so that it is a perfect representation of the slope of the blue line? Ladies and gentlemen, that is a nice official definition for how to find the derivative, how to find the slope at one single point. And it works out quite well, and I'm going to have you write several of these. We solved them last chapter, now we're going to learn how to write them and solve them. It's a great review. And I want you to know that it doesn't matter which variables we use, it's the same concept either way. It's still the difference between two y coordinates on this f function, and it's the difference between the x coordinates, whether it's the letter x, c, h, or t.